section, you are going to learn about a new kind of function called an accumulation function. This is the first part of section 6.4. It's not the whole of section 6.4. So when you were in elementary school and you first were learning about functions, you probably had some teacher who worked with you on function machines. And a function machine just says, okay, if I have an input and something inside of the machine is happening, and then I have an output, and so you have to kind of figure out what the rule is, or make the rule first, and then you have the input, and then the outputs come out. So when you were in elementary school, maybe it was a rule like y equals x squared, and so your input is -3, say, and then your output would be 9. And so you had a function machine when you were in elementary school. We are going to make this function machine handle calculus. And so my rule is going to be, for this particular function machine, I would like the area below f of t, here's a graph of f of t, between t equals -2 and t equals x. So if my input, there's t equals -2. If my input is x equals 0, then what I'm looking for is the area between -2 and 0. So I'm looking for this shaded area. And so I can kind of count boxes and say, well, that shaded area would be 6 plus 2 times 2 is 4, divided by 2 is 2. So that shaded area would be 8. That's cool, but it's not very mathy looking, so we're going to just make it a little bit more mathy looking. And we're going to say, I would like to make use of that notation that we've been using so far, and that same rule that I described in words is going to be the integral from -2 to x of f of t dt. And that's going to be my function. So I already figured out that if x is equal to 0, my output would be 8. Now imagine that x is equal to 2. Well, if x is equal to 2, then I want the area from -2 to 2. So I want this rectangle here, which is a 3 by 4, so I want 12. Here's a 1 by 3 rectangle, so 12 plus 3. Here's a half. And here's 1.5. So it would be 15, 16, 17. And let's say then I would like to have the area from, I've already done from 0 to 2. What if I do from 0 to 3? Well, then I just need to take what I already have, which is 17, and add on this new slice, which would be 4.5. So that would be, make this 21.5 would be the output. Okay, so here's the accumulation function definition. An accumulation function is one that's defined as a definite integral, and a is a constant, but x is the independent variable. The accumulation function is called an accumulation function because it accumulates area between t equals a, and then the x coordinate changes, so it's going to accumulate the area between that t equals a and t equals x. Remember too that if f of t is velocity, then this accumulation function is actually telling us the distance traveled. Okay, so here is an example problem. I would recommend that you pause the video and give this a shot, and then I'll talk through it, and we'll go from there. So my accumulation function is defined as the integral from -2 to x of this f of t function here. So f of t is not changing as x changes. F of t is just sitting here on the page. But I'm going from -2, which is right here, until I get to my x coordinate. And the first one is saying I'd like to go to x equals 0. So that is just a triangle. It's a 2 by 4 triangle, so it would be 8 divided by 2, which is 4. Okay, now I want to go to 2. So I'm going to go this far out. Well, I already have 4, so I'm just going to accumulate a little bit more beyond that 4. There's this square, which is a 2 by 2 square, and then a 2 by 2 triangle. So I've added another 6, so f of 2 would be, I almost wrote 6, so that's why that was kind of weird. F of 2 would be 10. And then if I go to f of 3, well, I already have 10, but I'm going to add 2 more, so I'd be at 12. And if I go to 6, well, I've already got 12, but I'm going to add 4 more and another 1 more. So I'm going to add 5, which would put me at 17. Okay. So that's how the accumulation function works. I have one more example, and you should try this one on your own, and then I'll talk through it after you've tried it. All right, so my accumulation function this time is defined from -4 to x. So here's -4. I'm going all the way from -4 to whatever x is. And the first question is, I want to go from -4 to 4. Well, I haven't gone anywhere. So my accumulation is 0. Okay, then I want to go to -2. So at that point, it looks like I have 4 plus another 1. So I have 5. And I want to go to 4, so I'm going to accumulate a whole bunch more area at that point. This looks like it's 6 by 3, so this would be 18. And here's a 1 by 4, so that'd be 4. And then this is a 1 by 2, so that's 1. Each of these little triangles is 1. And so that would make me 22, 25, plus the 5 I already had would put me at 30. And then if I want to do f of 5, I'm going to get another 1, and then a 3 by 1, so 1.5, because it's a triangle. So then I would be at 32.5. All right, I hope this explains what an accumulation function is, and you should now be able to complete the accumulation function problem set on Khan Academy. And it's just that one additional one that you know how to do now. All right, have a good Wednesday. Thank you.